To BSc Main Physics, Semester 6, Paper 1, Solid State Physics. Band Theory, Unit 3, Band Theory continues, and this is class number S42, Carrier Concentration in N-type and P-type semiconductors. Carrier concentration in N and P-type semiconductors, class number S42. Today we see the carrier concentration in N and P-type semiconductors and also in intrinsic semiconductor. The first one is intrinsic carrier concentration. Intrinsic semiconductor carrier electron concentration. The average behavior of electrons in the semiconductor is explained by the Fermi-Dirac distribution function F is equal to 1 by 1 plus e raised to EF minus KT, equation number 1. അതായത് ഇലക്ട്രോൺസിൻ്റെ ബിഹേവിയർ നമ്മൾ എക്സ്പ്ലെയിൻ ചെയ്യുന്ന ഒരു ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷനാണ് ഫെർമി ഡിറാക്ക് ഡിസ്ട്രിബ്യൂഷൻ ഫംഗ്ഷൻ. അത് നിങ്ങൾ പഠിച്ചതാണ്. അതിൻ്റെ അപ്പിയറൻസ് ഇതാണ്. എഫ് ഈക്വൽ ടു 1 by 1 plus e raised to E minus EF by KT. The Fermi-Dirac distribution function is F equal to 1 by 1 plus e raised to E minus EF by KT. E is energy, EF is the Fermi energy, K, small k, Boltzmann's constant, T absolute temperature, and E is the base of natural logarithm. From free electron theory, it is found that electron density of states is free electron theory നിന്ന് ഇത് വെച്ച് ഇലക്ട്രോൺ ഡെൻസിറ്റി യൂണിറ്റ് വോളിയത്തിൽ എത്ര ഇലക്ട്രോൺസ് ഉണ്ട് എന്നുള്ളത് കണ്ടുപിടിച്ചിട്ടുണ്ട്. അതിൻ്റെ ഇക്വേഷനാണ് ഇവിടെ കൊടുക്കുന്നത്. From free electron theory, it is found that the number of electrons per unit volume, electron density, is given by NNE. Number of electrons having energy E is equal to 1 by 2 pi square into 2mn by h cut square raised to 3 by 2 E minus Eg raised to 1 by 8. You see the relation 1 by 2 pi square into 2mn by h cut square raised to 3 by 2 E minus Eg raised to 1 by 8. Here Mn is the effective mass of electron in the semiconductor, in the material, which may be different from the rest mass of electron. H cut is h by 2 pi, is the energy, and Eg is the band gap energy. Mn is the effective mass of electron in the conduction band. The second title is electron concentration in N-type semiconductor. N-type semiconductor. If EF is the F is suffix, if EF is Fermi energy, Eg is the band gap energy, Eg is the band gap energy, then number of electrons per unit volume, the carrier concentration, electron concentration is given by N is 2 into Mn KT by 2 pi h cut square raised to 3 by 2 e raised to EF minus Eg by KT. EF is the Fermi energy and Mn is the effective mass of electron in the conduction band. This relation gives the density or concentration of electrons in the conduction band of an intrinsic of electron in a conduction band, intrinsic semiconductor. Hole concentration in the valence band. If Mn is the effective mass of hole in the valence band, hole has an effective mass, it is supposed. In the valence band, we write P is equal to, number of holes is equal to 2mb KT raised to 3 by 2, 2mb KT, 2 into mb KT by 2 pi h cut square raised to 3 by 2, E raised to minus EF by KT. There is no Eg in this expression. You carefully note the relation. Number of holes is equal to 2 into mb KT by 2 pi h cut square raised to 3 by 2, E raised to E minus EF by KT. EF is the Fermi energy, K is Boltzmann's constant, and T is absolute temperature. This gives the whole concentration in the valence band. So the three equations we have seen, and then there is an important law which is called law of mass action. Law of mass action. In semiconductor, we have electron density as, we repeat the equation. We have the electron density as N is 2 into Mn KT by 2 pi h cut square raised to 3 by 2 e raised to ef minus eg by kt, and p, whole concentration. And whole concentration P is equal to 2 into mbkt by 4 pi h cut square raised to 3 by 2 e raised to minus f by kt. Number 2 relation. We multiply equation 1 and 2. We multiply equation 1 and 2. We get n into p is equal to 4 into kt by 2 pi h cut square raised to 3. 3 by 2 into 3 by 2, that is 3. We have to add powers. Into mn into mb raised to 3 by 2 e raised to minus eg by kt. Ef will cancel. Ef term will cancel. Put 4 into k by 2 pi h cut square cubed into mn into mb raised to 3 by 2 is equal to a. That is, in the above expression, in the first part of the expression, we have to write as a excluding t. Excluding temperature, that is, put 4 into k by 2 pi h cut square raised to 3 mn into mb raised to 3 by 2 is a, which is a constant. When we put like that, we get a new equation in the form n into p. N into p is equal to 80 square, 80 cubed, 80 cubed e raised to minus eg by kt, equation number 4. This equation 4 shows that the product of electron and hole concentration of a given material is a constant and is constant at a given temperature. അപ്പോൾ ഈ എൻ്റെ പിയുടെയും ഒരു പ്രോഡക്റ്റ് കോൺസ്റ്റന്റ് ആയിരിക്കും ഒരു ഗിവൺ ടെമ്പറേച്ചറിലെ. ഫോർ ആ ഇൻറ്റർനെറ്റ് സെമി കണ്ടക്ടർ. ഇപ്പം നമ്മൾ ഇത്രയും പറഞ്ഞ ഇൻറ്റർനെറ്റ് സെമി കണ്ടക്ടർ കാര്യമാണ്. ഇപ്പോൾ ഇൻറ്റർനെറ്റ് സെമി കണ്ടക്ടറിൽ എൻ ഇൻറ്റു പി ഒരു ഗിവൺ ടെമ്പറേച്ചർ കോൺസ്റ്റന്റ് ആയിരിക്കും എന്ന് പറയുന്ന ലോ ഓഫ് മാസ് ആക്ഷൻ. എൻ ഈസ് ഈക്വൽ ടു പി ഈസ് എൻ ഐ is the intrinsic carrier concentration. So equation 4 becomes, or it can be rewritten as n into p is equal to ni square is equal to a t cubed e raised to minus eg by kt. It is a t cubed relation. Equation 5 is an important relation and is called law of mass action. Equation 5 നമ്മൾ law of mass action എന്ന് വിളിക്കും. This relation is true for a semiconductor regardless of donor or acceptor concentration. But donor acceptor concentration depend ചെയ്യാതെ ഇത് semiconductor constant ആയിരിക്കും. The question is state and explain law of mass action. ഇനി നമുക്ക് ചില പ്രോബ്ലമാണ്. ഈ പ്രോബ്ലത്തിൽ വരുന്ന ഇക്വേഷനെല്ലാം നിങ്ങൾ ബൈ ഹാർട്ട് ചെയ്യണം. There are some problems. The derivations of the equations are not included. You simply study the relations, and these are all previous questions, university questions, so you have to study them well. The conductivity of intrinsic silicon is 4.17 into 10 raised to minus 5 and 4 into 10 raised to minus 4 SI unit respectively at 0 degrees Celsius and 27 degrees Celsius to determine the average energy gap, average band gap of silicon. അപ്പോൾ സിലിക്കണിൻ്റെ രണ്ട് ടെമ്പറേച്ചറുള്ള റെസിസ്റ്റിവിറ്റി പ്രത്യേകം പറഞ്ഞിരിക്കുകയാണ്. ബാൻഡ് ഗ്യാപ്പ് കണ്ടുപിടിക്കുക. അപ്പോൾ അതിന് നമ്മൾ ചെയ്യേണ്ടത് സിമ്പിൾ കാൽക്കുലേഷൻ, ഈസിയായി കണ്ടുപിടിക്കേണ്ടത്. അപ്പോൾ ബാൻഡ് ഗ്യാപ്പ് എനർജിയും കണ്ടക്ടിവിറ്റിയും തമ്മിലൊരു റിലേഷൻ ഉണ്ട്. അതിന് ഡെറിവേഷൻ ഇല്ല. ഇവിടെ ഇക്വേഷൻ ഒന്ന് പഠിച്ചു കൊള്ളണം. പ്രോബ്ലം ചോയ്സസ് ഉള്ളതാണ്, അതുകൊണ്ടാണ് ഇവിടെ കൊടുക്കുന്നത്. Eg by 2k into 1 by T2 minus 1 by T1. രണ്ട് ടെമ്പറേച്ചർ T1 and T2. Two temperatures are given. Eg by 2k into 1 by T2 minus 1 by T1 is equal to 3 by 2. There is no minus sign. 3 by 2 log T1 by T2 minus log sigma 1 by sigma 2. T1 is 0 degrees Celsius, 273K. T2 is 27, 300K. Sigma 1 by sigma 2, we calculate a 4.17 into 10 raised to minus 5 by 4 into 10 raised to minus 4. And Boltzmann's constant K is 1.38 into 10 raised to minus 23. Jk raised to minus 1. We put all the values in the equation, we get Eg by 2 into 1.38 into 10 raised to minus 23 equal into 1 by 300 minus 1 by 273 is equal to 3 by 2 log 273 by 300 minus log sigma 1 by sigma 2. You put the value sigma 1 by sigma 2, calculate Eg, there is some calculation. You can do it by a calculator, then Eg will work out as 1.774 into 10 raised to minus 19 joule converted into EV by dividing it by 1.6 into 10 raised to minus 19. You convert the joule into EV by dividing it by 1.6 into 10 raised to minus 19 joule. We get Eg is 1.107 EV. That is the answer. That's the band gap. You remember? The band gap of semiconductor is usually about 1 EV. The problem goes with it. Another short answer question. If the lattice constant of a semiconductor is decreased, then what will happen? Happen to the width of conduction band EC, band gap energy EG, and valence band EV. അപ്പോൾ അത് ലാറ്റിസ് കോൺസ്റ്റന്റ് ഒരു ക്രിസ്റ്റലിൻ്റെ ലാറ്റിസ് കോൺസ്റ്റന്റ് നിങ്ങൾക്കറിയാം. ലാറ്റിസ് ഇപ്പോൾ ക്യൂബിക് ക്രിസ്റ്റലാണെങ്കിൽ അതിൻ്റെ ക്യൂബ് എഡ്ജാണ് ലാറ്റിസ് കോൺസ്റ്റന്റ് എ എന്ന് പറയുന്നത്. അത് കുറഞ്ഞാൽ ഈ വാലൻസ് ബാൻഡിന്, കണ്ടക്ഷൻ ബാൻഡിന്, അതുപോലെ ഫോർഗ്രൗണ്ട് ബാൻഡിന് എന്ത് ബാൻഡ് ഗ്യാപ്പിൽ എന്ത് മാറ്റം ഉണ്ടാകുമെന്നാണ് ചോദ്യം. If the lattice constant of a semiconductor is decreased, then what will happen to the width of conduction band EC, band gap EG, and valence band EV? The answer is EC and EV decrease and EG increases. This is explanation. The explanation is given here. Lattice constant is the side length of the cube, crystalline cube. Lattice constant, you read as lattice constant. Lattice constant represents the distance between molecules or atoms which construct the lattice. So generally, decrease in lattice constant means the electrons are more tightly bound to the atom and hence require more energy to remove, leading to increased band gap. But lattice constant കുറഞ്ഞാൽ ഈ ആറ്റംസ് എല്ലാം ടൈറ്റ്ലി പാക്ഡ് ആയിരിക്കും. അപ്പോൾ കൂടുതൽ ശക്തി വേണം, കൂടുതൽ എനർജി വേണം ഇവയെ സെപ്പറേറ്റ് ചെയ്യാം. അതുകൊണ്ട് ബാൻഡ് ഗ്യാപ്പ് എനർജി കൂടും. ഓൺ ദി അതർ ഹാൻഡ്, ഡ്യൂ ടു ഷ്രിങ്കിങ് ലാറ്റിസ് പാരാമീറ്റർ, വാലൻസ് ബാൻഡ് വിഡ്ത്ത് ആൻഡ് കൺസ്ട്രക്ഷൻ ബാൻഡ് വിഡ്ത്ത് will decrease as well. Some more equations are here. You have to study them also. Give expressions for Fermi energy, Fermi temperature, Fermi wave number, and Fermi velocity. Give expressions for Fermi energy, Fermi temperature, Fermi wave number, and Fermi velocity. Some important terms are here, or you have to study them. Fermi energy F is h square by 2m into 3 pi square n by v raised to 2 by 3. N by v, capital N by v, Avogadro number by molar volume, we write a small n, electron density. Then we get h square by 2m into 3 pi square n raised to 2 by 3. Here n is electron number density, small n is n by v. The Fermi temperature is given by Tf is Ef by Kb. Kb is small k, Boltzmann's constant. And now the Fermi wave number Kf is 3 pi square n raised to 1 by 3. Remember 1 by 3. The Fermi velocity is given by Vf is h by m kf, that is h by m 3 pi square n raised to 1 by 3. Then there is a problem, 2022 April problem. calculate the Fermi energy of sodium BCC where lattice constant is 4.3 angstrom. Fermi energy EF is h cut square by 2m into 3 pi square n raised to 2 by 3. You see, sodium is BCC. There are 2 atoms per lattice of volume A cubed. ഇപ്പോൾ ബി സി സിയിലെ ഒരു യൂണിറ്റ് ക്യൂബിനകത്ത് 2 ആറ്റമാണ് ഉള്ളത്. Each sodium atom has one free electron. It is 2 by A cubed 2.6505 into 10 raised to 22 centimeter raised to minus 3 is equal to 2.6505 into 10 raised to 28. EF is h cut square by 2m 3 pi square n raised to 2 by 3 that you calculate and convert in EV, we get 3.24 EV. Number 2, calculate the Fermi wave number. Fermi wave number, Fermi velocity and Fermi temperature of sodium. Fermi wave number is 3 pi square n raised to 1 by 3. That is 3 pi square into 2.65 into 10 raised to 28 raised to 2 by 3. This number we have copied from the previous problem. We get 9.224 into 10 raised to 9 meter raised to minus 1. Then Fermi velocity Vf is h cut kf Fermi number by m, that is 1.055 into 10 raised to minus 34 into 9.224 into 10 raised to 9 by 9.1 into 10 raised to minus 31 is 1.067 into 10 raised to 6 meter per second. Then the last part, Fermi temperature is EF by K, Boltzmann's constant. EF also we have written from the previous problem. Otherwise, it will be given in the question. EF is 3.24 EV. We convert into joule by multiplying it by 1.6 into 10 raised to minus 19 by K. K is Boltzmann's constant, 1.38 into 10 raised to minus 23. The answer is 3.76 into 10 raised to 4 Kelvin. That is all with your 42nd lecture. We go to the next chapter, next unit. Thank you very much.